I was interested in talking about and maybe getting some people to look at. It's based on an idea that I have that I'm working on, and I've written some code in just to experiment with. And so I figured I would show you some of the code that I've written and kind of explain what it's doing and maybe get some feedback. You can feel free to basically interrupt me at any time during this presentation and ask me what I'm doing or why I did certain things, and maybe I'll have an answer or maybe not. But anyway, we're just going to walk through this. So first thing, if you've never used a playground, by the way, they're really cool. The first line here is interesting. I need this because this playground uses some asynchronous code. And so a playground, if you've never used it before in Xcode, you can basically type code in and it will execute it and give you the results. It's a really great way if you have some new programming idea that you want to try out and see if you have an algorithm, if you want to just experiment with something before you include it in your project. I really recommend looking at playgrounds. And if you are, just remember you can use this line and you can also execute things in the background. You would need this if, for example, inside of your playground you want to make a network request and have it come back or something like that as well. So just a tip to remember. Getting into the idea that I'm interested in. So I like databases. And one of the things I really like about databases is the concept of a transaction, which is effectively that when you are modifying some data, you can effectively say all of these modifications can happen together, and if any one of them fails, the whole thing will fail. So essentially it helps you to have some confidence that if you're making some type of change to data inside of your app, or inside of your project, or inside of your web service, actually, wherever you're using a database, you're basically confident that if you're changing something and something goes wrong, that you're going to end up in a position where what you had before is okay. You didn't completely mess up everything. The transaction failed, and hence what was there before is still there. I like this idea about doing data, and so I was kind of interested in thinking about the idea of a transaction for just let's say, a normal array in my app. So rather than directly using the indexes of the array to modify the data, what if I would essentially encapsulate all of the operations that I'm going to do to that array and then apply them at one time. And there's a couple reasons why I was interested in this. One reason was because I liked the idea of the integrity. The second reason was because I thought if I could encapsulate all of the transactions, I could also reverse them, and if I reversed them, then I could basically implement undo. So I would have an array, I'd apply some operations to it. If I reverse those operations and apply them back, if I inserted something, then I reverse it such that it was remove, then the array would basically be in the conditioned state that it was before. So essentially you would kind of get an undo functionality for free. Does that make sense? Just apply some things, and then if you reverse it and unapply them, you just did an undo. And the second reason why was because I was interested in if transactions would help writing something that are multi-threaded. So the reason why I thought this might work would be that if you have an array and you're changing that array on multiple threads, if you're writing new content to an array from different threads, you occasionally have to worry, you might modify this thing and this thing, when a different thread, it's actually remove that thing before this got a chance to modify it, and so it can cause crashes or things like that. That's a common, it's a common problem that you have when you're writing code that has things happening on multiple threads. And as a consequence, if you could incorporate all of the changes, so my idea is basically, one good way to avoid that is if you have some data structure that you are modifying, you only ever modify it on one thread. So essentially you have one thread that can do all the writing on that data structure, and maybe you can read it from other threads as long as they're not changing it. But if you only write on one thread, then you can avoid some of the strange errors that can occur if you try to write to the same data structure on multiple threads. Does It's a little bit of an advanced thing. I have an example of that. But that's one of the things I wanted to see, is if I can basically write a transaction and then only apply those transactions on the same thread, then it will solve this problem. Anyway, those are the reasons why I did this, and now I'm going to show the code and just walk through an example of what this looks like. Yes, and the question already.
It sounds very similar to flux or redux, is it?
I do not know. Okay, actually, I kind of know some things about flux or redux. It's not JavaScript. It's just modifying an array. So I mean, flux or redux is a pattern, and it also kind of relates to of the data is.
Your actions come in one way, and it propagates out.
I guess what I'm saying is more, this might be a means by which you would implement something like that, but it's not necessarily a data pattern. It's just that I'm encapsulating all the changes to an array in a data structure, essentially.
Okay.
So it could be used to implement flux or redux or something, but that's a little bit of a different, I think, application concern maybe. That'd be my thought. So anyway, so in order to build this, the first thing that we need to have is an operation. So this is essentially the things that I can do, the actions that I can take. And actually, although I call it an operation, really you can think of this as an array operation. I'm only interested in what I can do to an array. This will not work if this data structure is a dictionary. You would need a different type of thing. So, this operation in Swift is an enumeration that has 3 different actions that I can do. So basically, it takes 2 things. There's the actual object that I'm operating on, and then there is the index where I'm going to modify it. So this is an insert, and here, one of the things that might be interesting if you haven't seen generics in Swift, this is an example of using it. So I made it a generic type because then I can use it on any type of array that exists. So basically, it doesn't really matter what type T is. It could be any, it could be an integer, it could be a double, it could be core location objects, it could be anything. Essentially, I'm just saying this operation can work for any type of array that exists that I might have content for. And there are 3 things I can do. Insert something so I can basically insert at some index. I can remove from some index, or I can move from one index to another index. One interesting question is, do I actually need the third one? Because isn't removing the same thing as just taking it out and inserting it back at a different index? And the answer is, I may or may not need that particular one, but I included it for one specific reason, which I might allude to later. The other thing that I did is I made it conform to equatable. So this is less complicated than it looks like from this. But there's one reason why I made it work with equatable, which is that I wanted to be able to test it. So effectively, I wanted to be able to write a unit test that says, like, I did these things. Like, this function has these transactions. It has like an insert 1 here, insert 2 here, return that result, and then in my test I can just say, like, this transaction is equal to another transaction. I can show you that later. The most interesting thing that this operation class does is, or this operations enum does, is that, or that might be interesting to see, is because it conforms with equatable, I wrote 2 different things. Yeah, let me explain this a little bit better. In Swift, when you want to conform to equatable, you have to provide a function called equals equals, and it needs to be able to take 2 things of the same object. So you have an equals equals, and you have 2 things which are both of the same type, operation T, and I implemented 2 different versions of this. In one case, I did it where T itself, that is the element that the operation has, like if it's an operation int, for example, if it's an integer operation, integers are equatable. I can say like 1 is equal to 1 or not. So in that case, shouldn't type in non-complete code. In that case, it will basically just compare and say that one operation equals another operation if the same sequence is, it has the same sequence of things and it's the same values. If you want to see what I mean by what an operation looks like, maybe I should go down to the example. Like this is what an operation looks like in practice. You would have an operation, maybe this one inserts, the window is too small. Try to keep the window really big, and it's a problem. So this operation here inserts a 1 at index 0, and inserts a 3 at index 1. So essentially this is what ultimately the operations look like. And I'm saying the two things are equal if you have, if another one also has two insert operations at the same object in the same index, which really makes sense if you think about it. Like if I insert 1 at 0, or if I insert 3 at 1, that is the operations, and another set of operations equal to it if they do that exact thing. That's what I wanted to compare. And the main thing here is so to make it conform to equatable, I had to include two functions, one of which was when t itself is equatable, when it was like an integer, and if it's not, I just say that they can't be compared. Anyway, I'm going to move on from that. And then the advantage of making operation comparable is that it's easy then to make my transaction class comparable like this. I just compare, does a transaction, do all the operations in that transaction, are they all equal? Then the transaction itself can be compared. That's just one interesting aside. You can ask more questions about that later maybe. So then what is a transaction? A transaction is really just a series of operations. So it would be like I insert 1, I remove 1. We could see it down here. A transaction just takes a bunch of operations, and an operations is just an array that has, you know, insert, remove, whatever, and that's going to apply those one by one to the array. So you insert something at 0, you insert something at 1, and maybe you remove at 3, or something like that. Maybe you remove whatever is at 3, 2, 1. So essentially a transaction is a sequence of operations, and this is what my transaction has. So it has a collection of operations, and I can either initialize it with an array of operations, or I can just add them, like make a mutable transaction and add, you know, index or inserts, remove, insert, remove, one by one. I can basically build out a transaction of things that I'm going to do. And the other one that was useful that I want to point out is it's also possible to reverse a transaction. So if I have a series that's like insert, insert, remove, reversing it would basically be remove, remove, insert. And then you can take a transaction and return the thing that is its inverse, essentially. And actually, writing these things, I almost want to not use the like display mode because it might actually be better to see because it looks way more complicated than it is, I think. See that? Yeah, that's a little bit clearer maybe what's going on. So really to inverse a transaction isn't that complicated. You just need to, if you're going to move something from this place to the other, you just remove it back to where it came from. If you want to remove, wait, sorry, is this the end? Sorry, there we go. I was too far down the code. So if you want to reverse a transaction, if you move something from one place to the other, then the way you invert it is to just move it back to where it came from. If you remove something, then the way you would invert the transaction is to just insert it, or put an insert of that object. So I took out this object, so to reverse the transaction, I just put that object back. So essentially you can just go through each transaction and run them the other way. And the other thing I had was the ability to combine transactions, which is really just appending them together. That's not so important here. But yeah, so this is all that the transactions that I'm doing are. That's how it works. And again, it's equatable, so I can compare two transactions and I can say that these have the same operations in them. If it's the same operations on the same elements in the same order, then they're equal transactions. And then finally, this is an example of using like an extension in Swift. I can apply that transaction to an array. So all I do is I extend array to be able to take transactions. And then this becomes a mutating function that really does exactly what you might think that it would do. You go through each operation, you see the thing that it is and what index it takes place at, and then you apply that thing. So if it's a move operation, I actually remove it and then insert it. If it's a remove, then I just take it out, and if it's an insert, then I insert it at the index. So you can actually just go through one at a time and apply each one of these operations to the array, and then at the end I modify that array so that it works, so that it becomes the thing that I apply the transaction to. The interesting thing about this is, as well, because I do this first on a copy of the array, then if anything goes wrong, for example, if for some reason I'm trying to, like if the array has like 5 elements, and for some reason one of the operations is like insert something at index 7, then that's a problem because the array isn't that big, it can't hold that many elements. So I also have exceptions. So if something goes wrong basically in the application of this transaction, then it's going to fail and the array will not become that thing. So it only works if everything works, if every operation makes sense to apply to the array. If something goes wrong, then those changes won't be applied to the array as a whole. We just make a copy of the array, do all the changes to it. If they all work, then we say that that array is the correct array. So that was all the theory about how it works. If you want to see an example, which I hope makes it a little clearer what I'm talking about. No, that's not what I want. The playground is not showing the results over here, is it? I'm curious why the playground has stopped running. Playgrounds are kind of hang on. Let me close it and open it again and see if the playground actually executes like it should be doing, and show you exactly how this works in practice. So it would be nice if on the gray area in that margin over there we go. Finally. So this is an example of what I'm talking about, which I hope makes that explanation clearer. Maybe I should have included these first. This is what I'm going for. So I have an array, then I have some operations that are going to modify that array, and then I create a transaction that has all those operations. I apply that transaction, and now you see I started with this array, which was empty, and now that array has 1 and 3. I inserted 1 at index 0, I inserted 3 at index 1. Then I applied transaction.reverse, so I just apply the reverse of that transaction, and then the array no longer has any elements in it because I reversed the transaction. That's effectively what I wanted to build with this model. The other thing that I'm interested in, which maybe gives an example of what I'd like to try with this, is let's imagine that for some reason this is an array that I only want to change on a single queue in the application. Like the subviews of a view is an array that I might want to modify in my iOS application. But because of the way iOS works, if you're dealing with UI like UI view, you're supposed to do those types of operations on the main queue, not on just any given queue. And you might actually have problems if you try to modify that array on a specific queue. So, but let's imagine that, for example, the thing, I want to change the view, I want to change those views, like maybe I want to change their frames or I want to do something to those, but the calculation to do that is expensive and would take a lot of time. If I do all that, it might be slow, like as I'm scrolling, you might find that it's a little bit jagged or something because I'm doing a lot of work on the main queue, and I would prefer to do that extra work somewhere off of the main queue, and only once I have the result, modify the subviews to reflect that result. So that's where you might want to think about doing something like this, when you're doing a lot of work and you want to take that work off of the main queue. So in practice, what I'm thinking about is a pattern more like this, where you, off of the main queue, inside of some type of queue, using like dispatch queue here, I have some operations, and then I apply these changes to it, and then once I have built that transaction, I apply it only on the main queue. So the work of updating, the only thing that happens on the main queue is the work of updating the application. So this is one example of where this type of thing might be useful. And second, so any questions up to here, because I'm virtually done and I only have a couple more things to add to where this might be interesting. So any questions up to this point about what I've talked about? Yes?
So like this could be used as like a way to check your array operations before they actually happen to prevent crashing and stuff?
Yes, that's actually one of the things I'm going for with this, would be like if you knew, like if you didn't, yeah, exactly that, like this will only work if all of those operations are there. So let's say, for example, you split your work among two queues, and they both wanted to apply modifications to the array, but those were in conflict with each other, and then you put it back on and you wanted to apply them, on this thread, then it would fail. One of those would succeed, but the other one would fail. So you could actually prevent your application from crashing, because you're basically, you do all the work off of it, but the whole thing will only succeed if both of those sets of transactions don't conflict with one another. So yes, that is actually one example. That's actually why I wrote this, but I didn't want to talk about that because it was already kind of a complicated presentation.
Oh, okay.
That I didn't do a great job of simplifying. But that's one of the things as well, is you could also combine the transactions and merge them and things like that. But there's a lot of cool things that can happen. One of the points I want to make is once I started thinking this way, like once I started thinking about isolating stuff in transactions, there's actually some cool stuff that I think I can probably do with this concept that I haven't even gotten close to covering yet. I'm only talking about the basic initial concept. But one of those things is you could merge transactions. The other one I'm interested in is minimizing transactions. So let's say that you insert an object and then remove it right away. Well, why don't you just have that transaction be nothing? Because you took it the same, if you took an element out, you put an element in and took it out. What if the transaction could be merged so that rather than having an insert and a remove, it just didn't do anything? That's also where I'd like to go with this idea that I did not put in this presentation. But right now I want to just talk about the core concept of it, which is that you have a transaction and then basically it's how to build it. Hopefully how you build it isn't too complicated to understand. It's really, although it looks complicated, it's less than 100 lines. It's 116 to include the extension and the equatable stuff and all of that. So it's actually a relatively short amount of code, and I think it's relatively clear to understand. But the main thing that I think is interesting that I want people to think about is when you start taking these operations and thinking about if I have a data structure that encapsulates the changes that I have, there might be some interesting things I can do with that. So my two initial examples are undo is pretty easy, and doing stuff multi-threaded is kind of easy. Any other questions or comments or anything? Okay.
You talked about the view array
Yes.
as one application for this.
Yes.
Are there other applications that you've already envisioned in your head that this could be applicable for?
In general, yeah. So core data might be another example, maybe, because core data uses thread confinement, although I haven't thought through all those implications because it also works on like sets rather than on arrays, so I don't know exactly, but that's in my mind, but I probably would need more work to make that same concept work here. But you could probably make like a core data transaction and then say like, I want to update my context in this fashion. So you don't pass the objects themselves, you just pass what you want to do to those objects onto the thread where you change them. That's kind of the idea. So that can be done on any thread. What you want to do to the objects can be built on any thread, and then you just pass that into the thread where you actually want to make the changes. That's effectively. So yeah, that's another example. In my app, what I'm actually using it for is just that I have an array. The current concept is I just have an array that I'm managing, and I'm not managing it on the main thread. But I'm only modifying this array on a specific queue. And I actually just created a queue, and I'm only applying the changes on that queue. Mostly because I think if I use a pattern like this, it will prevent me from making bugs. And also it's really easy to write tests, because I just have a function that admits a transaction, and then I just check in my test, does this transaction match what I think this should be doing to it? So that's the other thing that's kind of nice about this. I made a really big and perhaps somewhat confusing point about implementing equatable, but that's why I implemented equatable, was so I could write tests. Any other questions, comments? Yes. Oh yeah, that's right, you had one, Michelle.
Yeah, have you thought about the way you index your element one after the other?
Uh-huh.
To show what I mean is, take for example an array with 2 elements.
Yes.
And you will say, I want to insert one element at position 0.
Yes.
And next one you say, I want to insert an element at position 1.
Yes.
This is already ambiguous. You have 2 ways to interpret this.
To insert an element at index 1. Yeah, you're exactly correct. I do it by, so index 1, yeah, that's actually a really good point. So let's say, what is the meaning of the indexes? So let's say I have an array with no elements, and then I insert something at 0, then now I have a new element. So if the second operation is inserting at 1, does it mean 1 on the original array I had that had no elements, or is it inserting 1 on the new array that has now has just 0 in it? And the answer is the second one. So in my implementation, the order in which you apply the operations matters, because the index is referring to what just happened. So that's why, for example, if you insert 1 at 0 and then 3 at 1, the second insert operation is this 1 refers to the array that was created after I applied that transaction.
But this is an easy case because at the beginning you have nothing.
Yes.
So 1 wouldn't make sense.
Yes.
But
the second one,
if you start
matters.
with 2 elements, and you include the first one at position 0, and the second one at position 1.
Yes.
Is it after the one you just inserted, or after the one at position 1 at the beginning?
In every case, I'm just applying to the array that was created the previous time. So,
I mean the last state.
Yeah, the last state of it. And that actually has implications for this implementation, which I didn't get into very deeply, which is like the order in which I apply this. Like I couldn't reverse this and just say like, I couldn't do insert 3.1, insert 1.0, because it would try to insert 3.1 on an empty array and give me an error. So that is a very good point. So the way that I wrote this, the order of the operations does matter, and also whether or not you apply removes versus inserts matters a little bit too. Usually I apply my removes, in a transaction, I apply my removes first, and I apply them from the lowest index up to the highest index, because if you have a bunch of removes, right? So if I remove from 7, then if I know that that's the highest index that I remove something from, so I'm removing from, like, in this transaction, 1, 3, and 7. I want to apply 7 first because it won't change the indexes. So that's exactly what I do. I remove 7, then 3, then 1, so that there's no error. And then from the inserts, I apply the opposite way, going forward.
For insert, you can also apply backward, because it will not change what you had before the index of what you just inserted.
Yes, but anyway, Yes, that's true. I have to think about that. It does matter, is my point. I don't want to make a mistake in the implementation details, but it does matter the order that you apply things in this way of doing it. So that is a very good point for the implementation. And yes,
It's not a question, it's just a comment.
Yes.
This is interesting. I wonder if this kind of idea can apply for this, any structure or other classes for, like a transaction mechanism, like a commit or. I didn't know that you can actually modify the self itself by mutating function.
You mean like this?
Right.
Yeah, doing this at the end?
Right. So if you're using this mechanism, there might be able to even any structure or class, maybe in this particular situation, this is the structure, but you can, I don't know, there's a begin transaction kind of a combination, and then any modification you can make, and then either commit or rollback or. I just wonder if that this kind of idea can apply for any other array or dictionary.
Right. I mean, I actually did think about dictionary at one point. The thing about the dictionary was, of course, that you need a key rather than the type. The other thing I realized for a dictionary is I think you only need one operation, which is just to set. Because for a dictionary, setting something to nil is this equivalent of removing it. So if I want to remove something from a dictionary, I can just do a string, and then I could do the key and then set it to nil. And order doesn't matter in a dictionary, so you don't need to move or anything like that.
But insert usually relates to an order.
Yes.
Otherwise, it's just the same as add.
Yeah, one of the differences with dealing with an array, which is why I'm only really talking about an array operation, is that what you do to an array, order and sequence matters. To a dictionary, it doesn't really matter as much. It would matter if you change the same key inside of a transaction. Basically, if you modified the same key twice in one transaction, then which one did you actually need to set it to? But anyway, those are all interesting. Those are all things you can deal with if you want to apply this concept. I'm more interested in the concept than I'm interested in that there is one authoritative right way to do it. I'm most interested in the concept of encapsulate the operations in a data structure in some kind of structure, and then what happens. But how you actually implement it does have differences that might be important. So, okay. Any other questions or comments on what I've done here?
The class or struct protocol.
Uh-huh.
Equitable protocol
Yes.
is, I think, global method.
Uh-huh.
But I plan a safety plan,
Uh-huh.
private method. But equitable is global method.
Yes.
So transaction, I will config again. So generics protocol is equitable. Do you think private method?
I don't think it can be.
Oh,
I think that Swift requires it to be done in this way, because
yes.
so the one thing that is the one thing that's, even though it's global, the transaction it's still scoped by the type,
Yes.
and even if there's another type called transaction somewhere else, if someone in the future creates a transaction, actually this is Swift will scope this transaction by my project. So it's not like this is the only class in the entire namespace that is called transaction. If there's another transaction somewhere else, like this would be called, I don't know, whatever. This is actually, its name is my app.transaction is its real name, and it's scoped by that. So you don't actually have to worry that it will conflict with a different type of thing based on Swift's namespacing.
So because I think AI programming.
Uh-huh.
So nice generics plan, but very difficult AI programming. So I think private method and global method coding. So all global method very danger. So
Yes.
every day I think safety plan.
Right.
So, but nice generics programming.
Oh, thank you. Yeah, you're right in general. It is not a good idea to write global methods, and you should try to namespace your methods. In this case, this is how Swift requires. If you want to conform to equatable, you have to do this basically. So, and at least it's not so bad because the parameters are always scoped by the type, and the type is namespaced. So it's probably not going to cause any conflict that. But yeah, you do make a very good point about global functions, and try not to write them if you can help it. Cool. Any other questions?
About that equatable protocol.
Yes.
I guess in Swiss 3, you can write that function in declaration of the struct.
Possibly I can.
Static path or something.
Oh, if I make it a static inside of here.
Yeah,
let's try that.
So, in Swiss 3.
Cool. That might have been a feature of Swift 3 that I just never got around to realizing I could do. Cool. I'm going to try that because I agree that I've never really liked this. So I'm glad to hear if I don't actually have to do it. So apparently it's not respecting the indent key thing that I'm typing. Right? Okay. I'll do that later. That's good to know. Everyone, if you don't have to do this, that's good. So that's how I do it. It's static. Okay. If you don't have to do it globally, so then that is better. Cool. Any other questions or comments? All right. I will also point out two more things then that might be interesting about using this approach that I've also thought about. So one thing I was also interested in writing would be a function that looks like that, where given an array, I guess I should say that this is also an extension inside of an array extension. So imagine that an array has a function called transactions to become that takes another array and returns the transaction that will turn it into that array. This is very similar to like Myers diff or something like that. So actually I think with Myers diff you can't have a move method, I think. But, and since we talked about React and some things, like Myers diff has suddenly become very popular because Facebook is using it in, for example, their React framework to like figure out what changes are happening inside of your UI and stuff. So I am thinking about things like that when I'm doing this type of project. But if you had a diff, this is essentially a diff algorithm here. You could have one array, take another array, and determine what transaction is needed to turn it into that array effectively. I'm interested in that particular thing, and that's actually the same thing as a standard diff algorithm. The other thing that's potentially interesting and relates to why I have a move method is a UI table view happens to have these interesting three functions. So if you imagine that I have a transaction that already tells me what things are being inserted or removed from it, I can very easily turn it into the operations on the UI view. So I could actually both change my array and the UI that's showing that with using the same transaction. This is more suggestive, but is another thing that would be possible with this type of an approach. So, and that's my last thing. I'm at the bottom of my playground. So, any other questions or comments relating to this?
Yeah, just one little comment. The last thing you said about the table view.
Yes.
And this would probably work on collection views too. But separating out
Things as opposed to just having insert and remove, because then you can basically just look at your collection of operations and go through them and, you know, update your table view inside of its lock thing and, yeah, animate all of the changes you just made as well. Any other questions, comments? Cool. So if you got through all of the explanation of the code, the main point that I want to make again, just to focus that in, is more about the concept of doing this, of separating out what you're doing to a data structure from, and sort of encapsulating that in type of an object. Because when you do it, it I think leads to some interesting consequences that are interesting to explore. So